Hey guys, welcome back to my channel. Here today we will solve the IR spectrum C30 NMR and the proton NMR spectra for Cyclobromopentane. So here, first of all, IR spectra. As you may see here, there is no peak that is present that indicates the presence of any functional group in the IR spectrum. So what you will can conclude from this that no functional group, no major functional group is present here. Mass spectrum. In the mass spectrum, we did the molecular formula. Here you may see the molecular formula you are getting is 35H9 bromine. Here in this video, we will not solve it. We will solve the NMR spectra for this molecular formula. So now from your IR spectrum, you know that there is no functional group present, and from your mass spectrum, you already know that in your molecular formula or in your given compound, you have the bromine atom. So from your IR spectrum, you know that no functional group is present, and from your mass spectrum, you concluded that bromine is present. C13 NMR spectrum. In the C13 NMR spectrum, two spectra are given. First is depth and the second is proton decoupled spectrum. In the depth, we get the information that how many different kinds of the carbons are present. As you may see here, the indications are given that if the CH2 group is present, then your line will be in the downward direction. But if the CH3 and the CH group are present, then your line would be in the upward direction. So here, if you see that in the depth, there are three signals, 1, 2, and 3. So, in the first signal is in the downward direction, which indicate that CH2 group is present. And the second signal is also in the downward direction, which also indicate that CH2 group is present. And the one signal is in the upward direction. So it means that either the CH group or CH3 group is present. So this is the information that you obtain from the depth. The presence of CH2 group, two kinds of CH2 more specifically, and either the presence of CH or the CH3 groups. So now if you proton decoupled spectrum. Proton decoupled spectrum is that spectrum which tells you that how many types of the carbons are present. In the depth, you got the three kinds of the carbon. But it may be possible that the other kind of the carbon may be present which is not directly attached with any hydrogen. But the depth does not give us this kind of information. It only tells you three kinds of the carbon atoms. But in the proton decoupled spectrum, you also got the information that either the quaternary carbon means a carbon that is not attached with any hydrogen present or no. So, if you see here in the proton decoupled spectrum, one line is in the specific line, one line is in the line that is representing the CH2 group in the depth. So, it means that here CH2 group is present. And this line is also in the direction of the CH2 group in the depth. So it means that this line also representing the presence of the CH2 group. But this group is in the upward direction in the depth, and here is also an other line is present in the proton decoupled spectrum. So it means that here no quaternary carbon is present. Quaternary carbon means a carbon that is not directly attached with the hydrogen is absent. Okay. So now it may be possible CH or CH3 group. Okay, now if you see the chemical shift value here, this is the 0, 10, 20, 25. It means almost in the range of 23 to 25 ppm value. So this is representing a presence of the CH2 group. Similarly, this carbon is also below the 40 ppm value. So it means it is also representing the presence of the CH2 group. It may be possible that some kind of the electron withdrawing group is present with it, because of which its chemical shift value is increased. So here this carbon is coming in the range of 40 to 60 ppm value, or more specifically almost 52 ppm value. So it means here this carbon is attached with any group. You already know that functional groups are absent, so it means that it is attached with an electron withdrawing group. So now If you see in the mass spectrum, we know that our bromine atom is present. So it means this carbon is directly attached with the bromine. If you bromine atom, if we do the comparison of this line with the same line in the direction of the same line that is present in the depth. So here the two possibilities were present. It will be CH group and the CH3 group. If the CH3 group is present and it is attached with the bromine, then our structure is complete. So there is no possibility of presence of the CH2 group. So it means that here in the depth, the methyl group is absent, only the CH group is present that is attached with the bromine atom. So now you got the information that two kinds of the CH2 group is present and also the CH group is present that is directly attached with the bromine, as we have concluded it from the chemical shift value. From the proton NMR spectrum. So here in the proton NMR spectrum, I have given the values of the integration above each line that I extracted from this scale value. So here 1, 2, 3 and 4. We got the total 4 types of the signals, as you may see in the expansion. So the one type of the signal that is here in the range of the 4.5 ppm value, if we see it in the expansion, so it is a pentate. It means that it is giving you the K5 splitting pattern. So if we follow the n+1 rule here, n+1 rule, and we are getting the pentate mean 5 splitting pattern. So now in the neighboring, how many hydrogens are present in the neighboring? We will solve it from it. 5 minus 1, n is equal to 4. It means that here the 4 hydrogens are present in its neighbor. As the chemical shift value also telling us that this is the carbon that is attached with the bromine atom, because only the bromine atom is present that is electron withdrawing in nature in your compound. So it means it is giving you the information that here one hydrogen is present that is attached with the bromine, and because one hydrogen is present, why one hydrogen is present? Because the integration value is 1, and in its neighboring it is attached with the 4 hydrogen. It cannot be attached with the 4 hydrogen directly if the we goes now that CH4 in the case of CH4. So if we see here, it will be possible because except the CH group, only the CH2 group are present in our structure. Do you agree? And 2 CH2 groups are attached here because it gives us a pentate. Why the 2 CH2 groups are attached here to give us the pentate? Because here in your C13 NMR spectrum, only 2 kinds of the carbons was detected. One was the CH2 and the other was the CH group. So the CH group is directly attached here with bromine. So it means that it is attached now with the 2 CH2 group to give us a pentate splitting pattern. Okay, now if we see here and here, both here 2 hydrogens are present. We will solve it later. Okay, first the 4 hydrogens are present here. 4 hydrogens are present here. It means that it may be possible. Now only one CH was present, so we have only rewrite it only now the CH2 groups are left. Now if you remember your molecular formula, it was C5H9 and bromine. Now we have used our bromine. We also use our CH structures. Now the chemical formula that is left is C4H8. So now it may only the CH2 groups is left here. So it means that it may be possible that in your structure now 4 CH2 groups are present. And if you see here, this splitting pattern shows that 2 CH2 groups are attached here. And this integration pattern gives you the value that 4 hydrogens are present under this P. And here if you see the splitting pattern of this, you will see that here a type of the pentane is present, but the expansion is not that clear. So it may be possible here two CH2 groups are present because it gives you the pentane. So it means that this CH2 group is present, a kind of CH2 group is present which is attached with the 2 CH2 group in its neet ring like this. And now here the integration is 2 and here the integration is also 2. More specifically, now we know that only the CH2 group is present, so it may be possible one CH2 group is for here and one CH2 group is for here. 2 CH2 groups are here. So our four CH2 groups are completed here in these 3 peaks, and our CH bromine with the bromine, our CH group with bromine is here in this peak. So this structure is completed. But now what we want to see is its splitting pattern, because it also has some kind of splitting pattern. And now if we see their splitting patterns, you will see here, this is a kind of the quadrat here and similarly a quadrat here. So if we solve this quadrat for the splitting rules, you will see that n plus 1 is equal to quadrat. So it means that in your neighboring the 3 hydrogens are present. So if the 3 hydrogens are present, it means that your structure is attached with the CH2 group on one side and the CH group on other side. Similarly, it also gives you the integration value of 2, and that is your CH2 group and the pattern of some kind of quadrat. So similarly, this CH2 group is also attached with on one side with the CH2 group and on the other side with the CH group. So this is the pattern you are getting from the splitting rules and also from the integration value and from the chemical shift value. So now the structure that we elucidated for you is somewhat like this. CH group is attached with the bromine, and here this CH is attached in its neighboring with the 2CH2 group. And this is the CH2 group. You may see here that this CH2 group is attached with this on one side with CH2 group and on the other side with the CH group. So it means that here is also CH2 group. Okay, so if I say this is due to the peak 1, so this CH2 group is due to the peak 1 and this CHBr is due to the peak number 4, as this is the peak number 4. And this CH2 group is due to the peak number 2. This is the peak 2 and this also gives you the same pattern. So it means here the CH2 group is attached. Okay, now this is due to the peak number 3. This is due to the peak number 2. And this is the peak number 3. This gives you a pattern that CH2 group is present, 2 type CH2 group that is attached on either side with the CH2. This CH2 is attached with CH2 and here is also with CH2. And similarly, this CH2 is attached with CH2 and here is also CH2. So it means that this peak is due to the peak number. It means that the CH2 group is due to the peak number 3. Similarly, this CH2 group is due to the peak number 3. Okay, now this is your structure. That is the bromocyclopentane. But wait, here, as you may see here that this is the one kind of the proton that is directly attached with bromine. So it is chemically different. So it gives you a single peak. And these two CH2, as these both are attached with the same CHBr on one side and CH2 on other side, so these should be chemically equivalent and should give you a single peak in the proton NMR. But here, these 2 peaks we are getting. Okay, now if you see their chemical shift value are not that different. If you see here, it is somewhat in the range of 1.7 to 1.8 ppm value, and it is in the range of 1.8 to 1.9. It means that the difference between them is less than 1 ppm value or 1 ppm value. So it means that it has the same chemical environment, but their chemical environment is somewhat shifted due to the some kind of the atom that is present. As you know that here, if you see here, this bromine is attached with the carbon with the single bond, and here the ring is present. So it means that if this bromine can rotate around this carbon atom, it may be when it rotates, it gives us chemicals a slightly different chemical shift value to this CH2 group and to this CH2 group, because of which in the expandable spectrum we get the two peaks that are somewhat slightly different, that has a slightly different chemical shift value due to this reason. So this is the spectra of the proton NMR spectrum of the bromocyclopentane. Here, if I draw the structure neatly, you may see a pentane ring that is attached with the bromine. This is the bromocyclopentane. I hope you understand this lecture very well. If you like my videos, then please subscribe my channel and share my videos. Thank you so much.